is the sign. First positive, then it's negative. Then it's positive, then it's negative. Positive, then it's negative. So an example of an alternating series. Now notice it's raised to the n power, not to the n minus 1 power. That's okay. It could be n minus 1, n plus 1, doesn't matter. It's all the same. The point is it's alternating. Just to make sure we understand what's going on here, would you please write out the first 5 terms? So we're not going to be doing the test question tonight. That'll be Thursday night. We'll do the last 2 this upcoming Thursday. If for some reason you know you're going to be missing Thursday, you need to come up and talk to me. We need to make an arrangement before. Again, just to make sure that we have an idea of what's happening here, would you please take out your calculator and actually add up the first 5 terms? Let's get a feel of what's actually happening. You can get decimal approximations, that's fine.
I don't have mine. Hang on.
On my foot. So it's
Nice. Is it positive? Oh, it's negative. What time did you let you guys out last time? Like 8:30?
No, just better. Well, 8:45. Yeah.
What'd you get? Negative number or positive number? Negative number. Okay, so as we're going, notice that it's getting small, right? So as we look at this, we don't know if this is convergent or divergent. Maybe it is, maybe it isn't. I want to take a look at this one before I even introduce the test. Definitely an alternating series, right? Now this one seems like it should converge. Negative 1 plus 1 is 0. Negative 1 plus 1 is 0. Negative 1 plus 1 is 0. So we can think that way and go, you know what, it makes sense that it's going to converge. They're just going to cancel out forever. It's kind of telescopic. So I want you to take a minute, before I even give you the alternating series test, I want you to try to run one of those 7 tests to see if this series is convergent or divergent.
Do the telescope.
So before you start doing it telescopic, don't. Try another test.
Rude. Test for
What test can you
divergence.
use? Try the test for divergence.
I totally forgot how to do that.
What does
What's
that
that?
limit go
I
to?
totally forgot how to do that.
What does that limit go to? Plus minus 1, right? It's definitely not equal to 0. So what do we get by the test for divergence? What's our conclusion? The theorem states that if the limit of a sub n does not go to 0, it's divergent. So what's our conclusion in this case?
Divergent.
Divergent. Even though we can kind of see we're going to get -1 plus 1 is 0. -1 plus 1 is 0. -1 plus 1 is 0. We ran another test, it's definitely divergent. So we're going to need a test all in itself to test the alternating series. Now, what I want to do, are we clear on that? I want to erase that. Okay? Alright, I'm going to go back to this one. This is a definition of an alternating series. Would you please identify what a sub n is for this problem here? It's 1 over n, right? Meaning I could rewrite it like this. For this particular theorem, this is saying we're holding off the alternating part. Our a sub n is the non-alternating portion. This makes it a little bit more clear, right? So a sub n, for our purposes, is right here. We need to keep that in mind so that when I'm going to throw down the theorem here in just a second, we'll be able to do this. So here's the actual test. I'd like to erase this if I could. We'll come back to this one. Let me word it the way that I think. And I'll do it exactly the way they have it. Well, this weekend's going to be 18 hours of money closed. No, this one's empty. So we just have to satisfy 2 conditions, actually 3 conditions, pardon me. Now notice this one only tests for convergence. This does not test for divergence. However, if this limit doesn't go to 0, which test do you think I'm going to want to use? The test for divergence, right? Almost guaranteed. Decreasing is a no-brainer. If something's always increasing and you're adding up those pieces, for sure it's not going to converge. Again, you can run the test for divergence. Let's try one. call them alternating harmonic series. In this case, we already identified a sub n is 1 over n. Now, what do we know about a regular harmonic series? Convergent or divergent? Divergent. Our first criteria is it has to be alternating. I say this because when you get the project, sometimes you're going to get so desperate, you're like, can I use the alternating series test on a non-alternating series problem? The answer is no. It has to be alternating somehow. So first criteria, it is alternating. Second criteria, it has to be decreasing. Meaning, slope of the tangent line is always negative. This one's kind of obvious. Last criteria is the limit has to go to 0. What's this limit? 0. It's alternating. A sub n is decreasing. The limit goes to 0. What's our conclusion? Okay? So it's not that hard to use. Please take a moment and apply the alternating series test rules. What's a sub n in this case? Right. Should we confirm each axiom? When I used to teach this, we used to say a sub n had to be positive. I don't see that. Oh, it does say that. I missed this. A sub n has to be greater than 0. Yeah, that was always a which seems weird because if we think of this as a sub n, it's not always positive. But we don't. We think of this as a sub n, which is always positive for n equaling 1 and on. Okay. So let's take the derivative here. We can change this to this.
If you didn't have a negative base event, you just move it to the other term and have it start at different numbers.
If it's always positive after a certain point, then yes. If it's always negative, just factor in -1 and just focus on the 1. You're okay. But if it sometimes becomes negative and sometimes positive, then we have an issue. Here's the derivative. Oh, yeah. Again. When x is going to be starting at 1 and going on forever, do you see this will always be negative? We proved it's decreasing. What's the last piece?
I was like, that looks like 711.
Where does this limit go to? So our conclusion. How are we doing? Easy enough test? Yeah, this one's not too bad. I'm going to find